Okay, today it is 2.1 day 1. It's the start of a new chapter, chapter 2, and it's about functions. All right, we talked about this a little bit so I could get your subconscious working on it a little bit about functions. I'm just going to do a quick reminder. If I had the point 1 comma 2, and then the point 2 comma goes with 5, and the point 3 comma goes with 7, I can't even tell if it's a function, because I've never repeated any of the inputs. But if I repeat an input, like which one were the inputs, by the way? Yes, the x's, which are like 1, 2, and 3 in this case, okay? These guys. If I ever repeat one of those, that's the moment when you can tell whether or not the thing's a function, okay? Right now, since there's no evidence it's not a function, you can say it is. If they don't give you any proof it's not, then you can say, yeah, that's a function. As so far, as much as we know, it's a function. What if I put in one of the inputs again and I say, oh yeah, 2 goes with 7? Is that allowed or not allowed? It's not allowed. And this is the most important thing. I need you to write this down. I wrote it down myself to make sure that I can simplify it to one little tiny statement to see if it's a function. To see if it's a function, does any one input have more than one, what do you think I'm going to say? Output. That's the defining question. Because functions are consistent. Does that look consistent to you? No, I put in a 2, sometimes it comes up this, sometimes it comes up that. That breaks the rules. And I showed you before on a picture, that would be like this. If I put in x is 2, I got 2 different outputs, one at 5 and then one at 7. And that would break the vertical line test. And that's another one of the ways we can tell. Here's my function, and is it breaking the vertical line test? Yeah, it is. All right, so it's all about whether your inputs and outputs are breaking the rules. So here's the key question. Does any one input have more than one output? Okay, so here's another one that's like that. 2 comma 3, 3 comma 3, 4 comma 3, 5 comma 3. I know it's weird. The question isn't, is it weird? The question is it a function? I want you to graph those points very quickly for me. Graph those points quick. Take a sketch, quick graph, and then answer the question. Is it a function or is it not a function? Two comma 3, 3 comma 3, 4 comma 3, 5 comma 3, 6 comma 3. Do you get my point? I know that's weird to have it come out the same thing every time, but does it pass the vertical line test? Yeah. Therefore, it's function. Okay, here's the other question that I asked you before. Does any one input have more than one output? We really actually can't tell because we've never shown you any point twice. We've only done the inputs of 2, 3, 4, and 5. What if I throw in another 2? What should it come up as? 3. And it does. So that's legal. It's a function. All right, by the way, what if it's not a function? What's it called then? It's called a relation. If it's not a function, it's a relation. Because there's still a relationship between numbers. It's not like this graph doesn't exist. There is something that goes like that. Remember, it's not y equals x squared, it's... Say it louder if you know it. Yes, I like to say it the other way. Say it backwards from what you just said. Instead of y equals x squared, it's x equals y squared. And yes, that's the same thing as y squared equals x. Either way is fine. So that exists. It's not like these things don't exist. That exists. It's just not a what? Function. Why isn't it a function? Well, it doesn't pass a vertical line test. You could put in one input, like let's say that's 7, and get 2 different things, like positive 10 and negative 3. They exist, they're just not functions. Still a relationship between numbers. It's a relation. All right, moving on to this page. That is just a fun little game called NIM, but I don't have time to play NIM with you today. We got too much to do. I'll show you NIM some other day when we got an easy day. All right, so there are 3 ways you can tell if something is a function. I don't like this screen that much. I'm going to go to this next one. You can tell by its points. That's the one I've done with you a few times. Would you look at these points here and here? Is this one we have up here a function or not? No, because which one breaks the rules? Which input breaks the rules? 1, because it has 2 different outputs. All right. So next way you could tell is by graphing it. And if you just graphed these points, do you get if you graphed all these points that one of them at 1 over 1 has output of 5 and an output of 3? Do you get how this thing is not going to pass a vertical line test? All right, so that's another way. If you get stuck on the point thing, you can always graph the points and see if it passes a vertical line test. But there's a third way. The third way is, if you look at its equation, this is important now, every graph has an equation. It's not whether or not it has an equation. The question is whether or not its equation, when solved for y, gives you only one thing. So for instance, that one we just talked about, x equals y squared, is that solved for y? No. How do I solve it for y? Square root, square root, square root. Now all of a sudden I have square root of x equals y. True? False. Trying to pound on this. Square root of y squared is not y. What is it? Absolute value of y. So is that y alone yet? No. Still in the absolute value. So now you got to break it up and you're going to get 2 equations. Y equals square root of x and y equals the opposite of the square root of x, or negative square root of x. Notice, when I solve for y, I got 2 rules. That implies you might get 2 different outputs for 1 input. So bottom line, if you get 2 equations when you solve for y, then it's not a function. This would not be a function. All right, next page. And this is important for, not to actually do that page, sorry. Either add a page or find a good spot to write. This is another one of those nuggets that's really important. I can talk about x. I can talk about the domain. And I can talk about something else that means the exact same thing. X's are the domain, and they're also called the whats. I've said it 5 times this hour at least. Inputs. Those all go together. X's are domains, they're inputs. And what are the things that correlate with that as far as y goes? Y's and range and outputs. Okay. I'm going to pause for a minute and ask you to show me that and you with me. All right, so x, and I say, what is the domain for this function? I hope that this isn't too tough for you. Here is a picture of a function. First question might be, is it a function or not? What do you think? As far as you can tell, it is a function because it passes the vertical line test. Let's say it hits right here at 2. This is 1, that's 2. So it hits at x, no, the y-intercept, sorry, is 2. That's a little messy. I'm going to clean that up. So that right there is at 2. Okay. My question is, what's its domain and what's its range? Everybody write that like this underneath it. And I'd encourage you to write it in terms of something comma something. That's called interval notation. Write the domain and range of that function. This is something from higher algebra. I'm going to pause for a second while you do this, and then I want you to compare what you think the domain and range of this thing is with the kids sitting next to you. Rows 1 and 2 compare, rows 3 and 4, rows 5 and 6. I'll pause while you give that a try. So, the domain on this puppy is how far the x's go. Remember how domains are x's? And the x's go all the way from negative infinity to positive infinity. It goes forever. You can't just like say, oh, your graph stopped here at like 1, 2, 3, 4, 5, -6. Now the arrow is saying it's going to go forever in both this direction and that direction. Okay, and then the range on this guy. The range goes from 2 to infinity. What is slightly wrong with my answer? Good, a lot of people caught it. What do you say, sir?
Bracket.
Bracket, right there. Why? Because it hits at 2. 2 is included. It touches 2. If it was an asymptote right at 2 and it was like just barely not touching it, that would mean it wouldn't be 2, but that's not the case here. Okay, so we need a bracket. Good call. So let's get into the hardest part. This is the last and hardest part of the new lesson. And that is where we take functions and we stick things in them. This is baby functions, f of 4. You just stick a 4 in the function. But it is important to think about where you should stick it in the function. By the way, this just means that you are going to use integer rational numbers, I believe is what they're going for here. Or this means that this is just all reals. That could mean could be what the teacher was going for with that symbol. But don't worry too much about that. This is just using real numbers. Like you're not supposed to use imaginary numbers and stick them into things. All right, so if we're using real numbers, if I put in a 4 in this function, where should I put it? Well, when I say f of x, do you get that's the x's spot? That's where x should be? Do you get that they replaced x with a 4? So that's what you do. You stick the x or the 4 in the x. Well, where else could you have put it? You could have put it over here and replaced that with 4. That would have been wrong because that's not x, that's f of x. And this is important for you to get. Do you remember me saying that x's are this and y's are that? I never said what f of x was because f of x is the exact same thing as what? Y. This is exactly as if they had said y equals whatever. So whenever you see f of x, I want you to realize, oh yeah, that's the same thing as y. All right. So when they say f of 4, they're telling you stick a 4 in for the x. That can go right there. And then I can go 3 minus 4 squared. Does the order of that matter? Can I do 3 minus 4 first and then square it? It's going from left to right. That's what everybody says you should do. No. What should be first? 4 squared is 16. Powers have to come before. Please excuse my dear Aunt Sally. There's no parentheses left. There's exponents, though. Exponent has to be next. And then you multiplies and divides. And the last thing you do is subtract. All right, so 4 squared is 16. 3 minus 16 makes negative 13. How many of you had that before I even wrote it? Okay, good. That's the easy kind. You stick a 4 in for x. And this one, they don't want you to stick anything in for x. They're telling you f of x is 2. Do you get that's the same thing as saying y is 2? So obviously you don't stick it here. That's where x goes. They're telling me y is 2. Therefore, f of x, which is y, is 2. So a 2 goes right there. Could you then solve that for x squared? Absolutely you could. Would you please solve that now? And then whatever that is, you have found x. And you're going to put it there because that's the question. If f of x is 2, what's x got to be? Sometimes there's more than one answer. I'll pause for a second while you try that one. Okay, see how you did. If you put in a 2 here, you should start by subtracting 3 from both sides. Some kids get confused and think that the 3 was negative. This negative is not on the 3. This 3 is positive, and therefore I'm going to subtract 3 from both sides. I get negative 1 equals negative x squared. Next mistake people make is they try to take the square root right now. You can't, because the x is not alone yet. What's on the x I have to get rid of? Negative 1. I multiply both sides by a negative 1. And then that becomes positive x squared equals positive 1. Now I can take the square root. Square root, square root. Square root of x squared is x equals, square root of 1 is 1. X equals 1. False. What did I do wrong? Yes. Absolute value of x is 1, and that leads you to 2 answers. Especially today, it's a big deal. Do you remember that thing where if you solve for y and you get 2 different answers, then it's not a function? It's a big deal. All right, so the absolute value of x, that means x is 1 and x is -1, and that's 2 different things. Now, question for you here. This original function that we just did some stuff with, think about what it looks like. Isn't that pretty much just a flipped over parabola that's been moved a little bit? Picture what that looks like. Doesn't that pass the vertical line test? Yes. Now, I could see a kid getting all confused on this and thinking that they, with this, just proved by putting in a 2 that they got 2 different outputs. It's not really true. Tell me what the real situation was. Yes. Yes. So they put a 2 in as the what? 2 wasn't an input, 2 was a output. And these were the inputs. 2 different inputs had the same output. That's like a parabola. See, on a normal parabola like this, you check at like +2, you get 4. And at -2, you also get 4. Same output, different inputs. That's okay. Doesn't fail the vertical line test. So, all right. How many of you got 1 and -1 when you solved that problem? That's the vast majority of you. That's good. Next part is, again, I think a baby step up, no big deal, is to stick in a c into the function. So take this parent original function up here and stick a c into it in the right place. It says f of c. By saying this, did they tell you x or did they tell you y was equal to c? X is c. Very good. X is the thing they're giving us. X is c. So I stick an c in for x, which is right here. If I stuck it in here, I would be replacing y with c. They didn't tell me y was c. They told me x was c. So I'm going to put it not there, but there. Now when I stick a c in there, it's 3 minus c squared. That's it. Done. 3 minus c squared. Nothing to really do. Okay. This next one is f of c plus 1. That's still the x spot. That's supposed to be f of x, right? So they're saying make x into c plus 1. So now it's 3 minus c plus 1. Now this one has to be all multiplied out. I hope you don't fall into a little trap. Would you please take this, multiply it all the way out, and write down what you think the answer is. The answer has c squareds and c's and numbers in it. We'll see if you've learned that. That's one of the top 20s. It's one of the reasons that we do the top 20 early in the year, to try to help you practice multiplying things like this out. I'll pause while you try that. Okay, I'm back, and this has to be done first. Why? The parentheses are important, but I can't do anything in the parentheses. It's really not the parentheses that's forcing me to do it, it's the what? That's the exponents. Please excuse my dear Aunt Sally. Parentheses, I can't do anything. C plus 1 is C plus 1. Exponent I can do, though. So, C plus 1 and C plus 1. How many of you remembered to actually write it out and get all 4 parts of the answer? Good. Because it's first is c times c is c squared. Now some people are going, well, it's c squared and 1 squared. No, it's not. It's c squared, and then the outside and the inside. The outside and the inside make a c, and another c makes 2c. And the last is 1 times 1 is 1. There we go. That's what that is. But now I got to put the little negative in front of it. All of it in parentheses. Get how that parentheses is super important? Because that will force me to distribute the negative. So now it's 3 minus c squared minus 2c minus 1. Minus 1 goes with the 3 and makes a total of 2. Negative c squared minus 2c plus 2. I'm guessing only less than well, probably more than half, but just barely. Raise your hand if you had that one exactly right. Well, that's more than half. All right. That was tough because you had to stick in C+1. This is the toughest kind of them all. And that's where we end up today as our piece de resistance, the big one. If you can do this, you can do everything. F of x plus h. It's not that hard. Here's my function. 3 minus x squared, except I'm not writing an x. Why am I not writing an x? Because I'm going to replace the x with what? X plus h. Then minus f of x. Oh, f of x is that original function again. F of x is right there. 3 minus x squared. I just made a classic mistake right there. What I say is so important in this class, yes? Parentheses, yes. You have to have parentheses around this because that's a variable. And I taught you that every variable is an empty set of parentheses. And if you're going to put anything in it, you have to have the parentheses first. Then you drop something in. Why does it matter so much? Because if you just do it this other way, then it's just a -3 and a negative x squared. If you actually do it right, then it's a -3 and a positive x squared. Parentheses are huge. Okay, so now I'm going to do that. This is -3 and this is positive x squared. This part here is x squared plus xh plus another xh, which makes 2xh, plus h squared. And then still a 3 minus at the very beginning of this whole thing. And I did it again. What did I do wrong? Parentheses. Around what? All of this. What does it matter? Because I'll have to distribute the negative. So now it's 3 and a negative x squared and a negative 2xh and a negative h squared and a -3 and a positive x squared. And I already distributed that negative properly, which is why that became a positive x squared at the end. And last but not least, I put together like terms. A -3 and a positive 3, cancel. A negative x squared and a positive x squared, cancel. And all I'm left with is negative h squared minus 2xh. And if you want, I'd be okay with you reversing those two and putting the negative 2xh first. That's okay. And the last thing is if you can factor it, you should. So I can take out a negative h and then have h plus 2x. That's the same thing as this, except it's factored, and that's always a good thing. All right, so I'm okay with either of those two answers. I know that was a tough one, but I'm going to give you, I wanted to walk you through that one. I want you to try one yourself. This is actually a calculus thing that you're going to learn in calculus. You just don't know it yet. So this is telling you to stick x plus h into a function and then subtract that function. What do you need to be able to do this? A function. So here's your function. F of x is equal to 2x plus 5. I'll keep it simple. What is f of x plus h minus f of x? Pause for a second while you try that. All right. Got to get started. If you're not done yet, just finish up as quick as you can, and I'm going to do the earlier part that you're probably already done with. I'm going to stick in an x plus h into this. Where can I put it in that? Only in the variable. So I'm going to do 2 parentheses x plus h. Totally matters to have those parentheses. And then I'm just going to subtract f of x, minus 2x plus 5. Yes, I'm glad you're saying something. I did do that on purpose, yes. That has to have parentheses, and if you screwed that up, you just got it wrong. Because otherwise this negative won't go to both of them. This is a variable. It needs parentheses. Okay, so then 2x plus 2h plus 5 minus 2x minus 5, and the plus 5 cancel. The 2h, and this is supposed to be an h. No, it's supposed to be an x, sorry. 2x. Sorry, I just circled the wrong thing. That's the problem. 2x and the negative 2x cancel, and that leaves me with just 2 H is in hamburger. Raise your hand if you had that one right. I underestimated you. That is far more than 2/3 of the class. Good job. It's all about being careful with your negatives. That's it. You learned everything you need to know for today. Now, some of the questions are in a little bit different format, so I want to go over a few of them with you. So everybody see if you can find the homework for today. It starts right here, this little pink page. Off to the upper right-hand corner. You see that little thing right here? Is that an example of a function or not a function? That is not a function because one of its domain has two outputs, or no, one of its inputs has two outputs, or I could say one of its domain has two things in the range, because those are synonymous. Remember, input, output, domain, range. All right, so that's not a function. All right, number 2. Does anybody have any evidence that this is not a function? Yes, sir.
4 goes to both 2 and -9.
Exactly. Therefore, not a function. And therefore, you're done, because you only have to find the domain and range of those that are functions. So this one's not a function, so I'm done, because I can identify those 2 points, and it's not a function. Yes, sir? Why is this not a function? Okay, because one input, 3, has 2 different outputs, 5 and 7. One input has 2 outputs. And that's that very beginning of the lesson I read you that sentence. Does any one input have more than one output? That's the sentence you got to keep going back to. So if you get stuck, like in number 6, it gets a little weird. First thing I'm going to tell you is an irrational number. Irrational numbers, there's lots of them. There's unlimited number of them, but you don't see them every day. Like sticks, is that an irrational number? No. Can anybody name an irrational, and don't say pi, because that would be not. Actually, wait. Pi actually is a transcendental number, but it's also an irrational number. Okay, so pi works. Something other than pi. Weird kind of a number. What's special about pi? And there's other numbers that are like that. Yes, sir? Yes. Yes, sir. Okay, now what does that stand for, though? Okay. All right. All right. So there are some variables that are often associated with things like, for instance, phi, and phi is usually associated with 1.618, the golden ratio, but there's not too many that people are going to have memorized like pi. Okay, so anyway, I wanted you to give me a more common one, so he did. It was square root of 2. Pi is irrational also, but square root of 2, what do they both have in common? They have decimals that do what? They never end. They go on forever. And they don't what? They don't repeat. Okay, so anyway, those are irrational numbers. So what did they just say about the domain? X is the domain, right? The domain is a whole bunch of things. Like square root of 2. What about square root of 9? Would that be an irrational? No, because it comes out to a nice number, and that's not irrational. Okay, square root of 10? Yeah, that'd be irrational. Square root of anything that doesn't have a perfect, it isn't a perfect square. Okay, so moral of the story. To get x can be a whole bunch of things. Is that okay in a function for the domain, the x, to be a whole bunch of things? Yeah, I haven't broken any rules yet. All right, how about my y's? You can tell from looking at that what the y's are. What's the y always? 1. Does that break the rule? Here, I'm going to read you the sentence. Does any one input have more than one output? No, didn't break the rule. Another way to do it is graph a few of them. You'll figure out that this is the kind where they're all at the same height. Nothing wrong with that. Pass the vertical line test. So that is a function. Since it is a function, you have to now say, what's its domain and range? Domains are the x's. They tell you right there what the x's are. Now, you can't list this like 0 to infinity. How do I write my domains? You just write domain. And then you say it in words. What is the domain? All what? Irrational numbers. Good. Good enough. What is the range? Range is the same as what letter? the y's, also known as the f of x's. The f of x's or the y's, what do we know about the range? It's just 1. Do I going to say 1 to infinity? No, it can't be other things. It's just 1. All right. The next couple are yours to do. Then we get to these. They're pictures, much easier, because what test can you use to tell if they're a function? Vertical line, p, piece of cake. And now you just got to say what the domain is if it's a function. For instance, this one's a function. And since it's a function, I can say the domain and the range. And these you can just say with interval notation and be fine. If you ever want to say it in words, you can. By the way, the domain of this thing is all real numbers, so you could put this. That stands for all real numbers. What's another way to write that? Negative infinity to positive infinity. What's another way to write that? Write out the words all real numbers. There's a lot of ways to write the same thing. A lot of different notations. I am not requiring any particular notation for this. So just say the domain and range, whatever you think is the fastest way for you. All right. Next kind. This is where I have equations. What did we say about equations? How can you tell from an equation? I don't have the picture. I don't have points. I have an equation. I should do what to it? Yes, sir.
Solve it if you get more than a factor. If you get more than one.
No, solve it. You were right in the first place. Solve it for y, and if you get more than one output for that, more than one equation, then what? Then it's not a function. So this only has, it's already solved. Don't be tricked by thinking I have to like go from here and solve it. It's already solved. It's already got y equals. Has it got more than one thing that y equals? Like more than one equation? No, it just says y is this. I know this, if it had been absolute value, then I'd have to make 2 equations. This does not say absolute value. So this one, there's only one equation for it. It's right there. If y is only one thing, then it is a function. Yes, it's a function. Is this one already solved for y? Yes. Is it coming out with more than one equation? Nope, that's just an equation. I'm not solving for x. If I was solving for x, I'd have a problem. I'm solving for y. Y is already solved. All right, so don't overthink these. You just ask yourself, did y have, when you solve it for y, do you get more than one equation? All right, and then this page you may skip to save you some time because it's kind of a longish lesson for today. All right. And that's all I've got for you for today.